Hello, we are AVBotz, a high school team from Pleasanton, California, and these are the improvements we have made this year.
The main goal of MEC this year was making all task-based components quicker and more reliable. Our goal was efficiency, modularity, and crafting precision-oriented mechanisms, as well as collaborating with other divisions to enhance Marlin V2. For dropper, we continued with the tried and tested gravity-based design, but we modified it to drop both balls from one hole, a simpler yet more effective solution.
Our intake is an innovative collection mechanism that features 4 shafts connected at their ends using bevel gears. Attached to these shafts are surgical tubing sweepers which generate a vortex underneath the square. Positioned above these shafts is a collection box that allows us to capture any items drawn into the vortex, allowing us to capture props with minimal effort and minimal precision. Our grabber has seen several improvements since last year, including new thumb-shaped attachments mounted perpendicularly to its claw. These improvements allow us to grab vertically placed props such as the tube worm with ease and efficiency.
Last year we developed the sensor stack, which monitors the vitals of the sub. This year we added the pressure sensor and we changed the STM blue pill to the STM black pill, which increases the speed and quality of the sensor stack.
In last year's competition, we used the Flipski ESCs and CAN communication protocol to control our motors. However, this complex communication system was very hard to debug and used lots of intricate wiring. So, this year, electrical switched to the basic Blue Robotics ESCs, which, using PWM, we were able to control our thrusters, power, and movement more efficiently.
We also implemented new components to optimize the performance of our sub. We switched from last year's STM Nucleo 144 to a new Arduino ATmega 2560, which simplifies control code for software. We use KeyCat, a PCB design program, to create hats for more secure connections on the rack.
Lastly, we documented all of our submarines' electrical connections online using Draw.io, which helped with wire management and debugging.
This year, software focused on implementing an algorithm for hydrophones as well as other general improvements to the software stack.
This year, software decided to tackle the hydrophones task. So, in the hydrophones task, we needed to find a way to locate our pingers, and in our data there was a lot of noise, so we needed to use FIR filters to filter out this noise. Additionally, to calculate our bearing to our pinger, or the angle to our pinger, we decided to use the music algorithm, which works best in the alignment at which our hydrophones are placed in.
As we switched our communication protocol from CAN communication to PWM for our new ESCs, along with our microcontroller switch from a Nucleo to an Arduino Admega, software had to adjust its communication protocol in our microcontroller to accurately get sensor data and communicate with our thrusters.
So last year, tuning PID was kind of a hassle, so we decided to add this tool or this function onto our interface. So on the interface, we have the ability to add a set point, tune our PID gains, as well as see our control graph.